Special thanks to KU Ceramics Department Chair Marshall Mott for introducing me to Andy Brayman. Not long ago, Marshall and I visited Andy's studio, known as the Matter Factory in Kansas City. We walked through the space. As we walked through the space, Andy spoke about his work across all realms of technology and ceramics. He had CNC milled plaster molds, glazing experimentation, and collaborative robotic arms he was training to glaze tile, just to name a few. It was an inspiring mix of art, science, technology, and a little bit of alchemy. Andy is most interested in working through challenges that elevate craft and express techno-social relationships in material form. This is why the leading manufacturer for all things Terra Cotta established him as a ceramics, glazing, and forming methods outpost. Boston Valley Terra Cotta, located in upstate New York, is one of the most significant companies in the world with regards to the resurgence of architectural terra cotta, both in historic preservation as well as in contemporary application. Andy holds a Bachelor in Arts of Sociology, a Bachelor in Fine Arts in Ceramics from KU, and a Master in Fine Arts in Ceramics from Alfred University in New York. His exhibitions and curated work are too numerous to cover here today, but I can assure you he's very productive. The Matter Factory was founded in 2005 in Kansas City, and as he described it, as part artist studio, part laboratory, and part factory. Along with Boston Valley Terra Cotta, Brayman conducts research on glazes and forming methods to support architectural applications with firms that include Shop Architects, Kelly Clark Kelly, Kieran Timberlake, HKS, KPF, Handel, Perkins & Will, LMN, Studio Gang, and SOM. Surely you've heard of some of those firms. Please join me in welcoming Andy Brayman.
I'm going to just give an overview of my own practice and cover some of the work that I do that sort of falls into the realm of art. And then there's really mostly an emphasis on my work with this particular company, Boston Valley Terra Cotta. So I'll sort of start with explaining what that company really is. So this is the plant here. It's south of Buffalo, New York. And it's a couple football fields big. 150 people or so work there. And it's a really unique factory. It's, this is now moving on its own. It's okay. I think it stops when we get to the end of it. This is some of the work that they've made. This is not a rendering. That's an actual, this is a Ringling Museum. So it's ceramic on the outside. As a sort of shell. Right? And that's really what Boston Valley specializes in, is the exterior work, right? They don't make bathroom tiles, floor tiles, things like that. And ceramics is a difficult sort of material to work with, and companies usually specialize, right? And what Boston Valley, their roots really are as a flower pot factory, but they sort of found themselves making historic restoration. They restored the Solden building, the Guarantee building in Buffalo, New York, which was really sort of put them on the map as a company that could accomplish and make something complicated out of ceramics. So, half of their work is historic restoration, and then the other half is what would be called sort of new construction, right? And so, I mostly help with the new construction work, and I'll kind of get into where I fit in their company and what I do as we go on. So with ceramics, I mean, it's like we could start with just a basic question of like, why would you use ceramics in architecture? And I think it's a fair question. You know, there are some things about it that aren't particularly good. It's terrible in terms of tensile strength, right? It's great in compression, but it's terrible in tensile strength. And it's heavy compared to other materials. Some of the things that make it really unique are obvious, right? The glaze. The glaze is the sort of the first thing that you see when you're looking at a lot of terra cotta. There's beautiful terra cotta that is not glazed at all, but most new construction that I deal with anyways, the glaze is a really key component. And the glaze is sort of, it's magic. It's taking different materials that don't look anything like what they're going to look like when they come out of the kiln. Mix them. It is alchemy. You fire it, and what you get is a surface that is sort of a glass surface that's incredibly durable. It will probably outlast most of the materials used in the construction of the building. Right? And one of the other things that's sort of interesting about glaze is what you can compare it to. It's not aluminum. It's not powder-coated steel. It's not sort of surfaces and materials that we're used to that are incredibly uniform and are engineered to be really uniform. So, but before we get there, I'll start with sort of my own practice. So, I really studied to be a potter, and for years that's sort of how I describe myself, as a potter. And I'll still I think it's accurate to say that, but what it doesn't really kind of speak to is something that most people in ceramics have who work for a long period of time, which is you have to sort of do a lot of things. You have to be a generalist in ceramics. You have to know how to fix things. You have to design things for all these different stages in the process. It's all this sort of problem solving that sort of borders on kind of formal engineering, really, to some extent. And so that sort of framework has kind of led me to where I am today, in terms of how I spend my time and what I do with my energy. But this is a cup that has gold luster on it, and some of us might know that gold luster comes off in a dishwasher, right? Like if you wash china in a dishwasher, it's going to fade. You should hand wash that, right? So I took that idea and sort of played with that, and I printed some text on a series of cups and then covered them with luster so that over time, someone would be able to read what I wrote. And it's a gimmick, sort of, right? It's this kind of novelty, and a lot of my work hinges on that premise, something that it's sort of on the wrong side, it could be sort of gimmickry, and if it's on the right side, it could be interesting in a sort of hook or a lever to get something interesting happening in the object. So these are just some pieces that are from early kind of exploration and digital tools. So I think this plate was the first object that I used digital tools to make. And it's a really crude, it was an app, years ago, maybe 10 years ago, that you could draw little things on your phone. It was probably 8 years ago. And render them, right? So it was a real coarse, low poly would be the sort of way of describing that aesthetic. Low poly mesh count, basically. And that was the sort of basis for the plate. And to me, it was just interesting that you could design a plate on your phone. So the goal wasn't to make the most elegant, perfect plate, but sort of explore the tools that are at hand. And for people who work in ceramics, it's a material that is so deep in sort of nerdiness and technical kind of stuff, if you want that, right? If you're interested in sort of process, it's a material that is just so deep in that. It's a curse, really, for many people, in that you can get lost in just the process for the sake of process. And that's one of the things I continue to sort of struggle with and be aware of, self-critical of, when that sort of is just decadent and it's not really adding to the finished work at all. And sort of get paid to learn in some ways and push the work forward by collaborating with other companies or people. So the work made here, it's all sort of serial production, right? So it's usually objects that are not just made as a single one-of-a-kind thing, but something that's designed for a production of some kind. It was a production that's unlike what I deal with now, but the sort of basic kind of like workflow and problems sort of remain the same. Like, when does efficiency matter and when does it not? where can you cut corners, where can't you, all of those sort of problem solving things that really can make or break whether or not something is sort of successful. It's something that I, with so many other people in ceramics, especially where potters have to do. There's a lot of practicality involved in problem solving. So for the architects in the room, the digital tool set that I really started working with was sort of Rhino and Grasshopper. I sort of took on at the same time. I was skeptical of whether or not digital tools would take me to an interesting place, and I was, rightfully, I think, afraid that I could just get lost in that, right? Just lost in that process of learning software and seeing what really the sort of creativity of the software designers would do. Like, we all know there's in Grasshopper, you can use the, Voronoi, CAD or whatever component to make something geometric and look interesting. But you're really just, if you're not using it in a way that's interesting, you're really just displaying the sort of intelligence and creativity of people who sort of did this coding. So that's where Grasshopper for me became a really critical part with some of the digital tools where I could build some of my own. And that's been a big part of my practice, to sort of be able to do a lot of that on my own. So these drawings on here are all generated through esoteric methods of using a sensor to trace my hand movement and have that algorithmically make patterns that look like spirographs for people old enough to know what that is. That's essentially what they are. You have to sort of know the background story behind that if you were looking at this object to understand. But a lot of my work, I allow it to just exist on these levels where you don't have to know everything about it to appreciate certain things about it. This is probably the single object that best sort of describes that relationship between the digital and the physical for me, right? Where I'm literally taking the mesh pattern for the digital model and applying it on the piece and firing it in a way that sort of melts in and sinks in a way that I find beautiful as opposed to maybe like a logo on a cup or something like that. These are also vessels. These are, jump drives that are little ceramic jump drives, and sort of looking at expanding what a potter could make in terms of utilitarian objects and vessels. And there's part of me that sort of likes the fact that these are probably the biggest vessels I've ever made, in the sense that they could, contain, someone's library essentially, but they're tiny sort of objects. Vase. So yeah, this is the vase in the gallery, and this is the sort of vase, after trying to cast the first one. And this is really representative of ceramics. This is a humbling material. Just when you think you were sort of really good and you know what you're doing, it will humble you, And now that I'm working with sort of architectural scale, the stakes are sort of way higher, right? And so I have a new appreciation for sort of how conservative manufacturers can be. Like my views of manufacturing from maybe 5 or 10 years ago, really different than what they are now. And this is an example. The mold on the left, the pieces sort of, I've rigged up a system to be able to transfer it off. And the mold's prettier than the piece. They're more interesting, more sculptural, And that happens still sometimes, where the process is more interesting than the final thing. And I try not to get too hung up on that, I do still like the vase that comes out of this, but I'll try and figure out how to incorporate what I like in the mold, then maybe in the piece down the road. So here's these are some images of some collaborative pieces that I've done with other people. This is a piece that I made with some other artists. You may recognize Sarah up there. This is from, I don't know when, maybe 10 or more years ago. And they're large monolithic pieces, so a single piece of ceramic that were made for an artist, Neil Forrest, a Canadian artist. And so I have ram-pressed modules that go across this sort of large skin of ceramics, and the piece is on a cradle that is there. This is in the kiln. This is the cradle that's not part of the piece ultimately. This is a piece for Sherry Boyle, where I helped with both the digital side and then part of the manufacturing. This is for the Gardner Museum in Canada, which is a ceramics museum. And so this is sort of doing the problem solving, figuring out how we could make what she wanted, which is this sort of Humpty Dumpty-like figure that's going to go in front of, that, you know, is supposed to go in front of a museum next to a very stark, somber sculpture next to it. And so this is me sort of laying stuff out in Rhino, using Grasshopper to make this sort of crack pattern there, laying it out, figuring out, working with the structural engineer of how the structural tubing would go through what were bronze legs, how much the tolerance we had for the 3-inch outside diameter tube, and then that's it as it's installed. And so projects like this are really, I like, if, you know, assuming the collaboration works well, and this artist was really amazing to work with and great, and sort of understood the complexities of ceramics. And you know, the reason this was really able to work well, this is the grout line. That's the sort of fudge factor, right? That's where the tolerances would be taken up in terms of if things were slightly a different shape than you imagine, having this sort of grout line this way. And apparently for Canadians, this this pattern is something that was super common on all kind of like middle class China in Canada. I've never seen it before, but it has special significance to Canadians, I think. All right. So I'm going to go through the next stuff kind of quick. This is just some more sort of examples of me trying to make things that sort of are outside of the realm of a vase or a cup, and sort of trying to work larger with the idea of working at a kind of architectural scale at some point. And so this is a digital workflow that allows this to happen, laying stuff out, and then building the tools to cut the tiles out in wet clay digitally, so that, you know, the big promise, of course, of digital tools is sort of free variation, right? That's sort of what it's all about. And that's the kind of holy grail. Of course, it's that, you know, we should question whether that's like worth attaining. I think that there's plenty of discussions to be had about the problems of digital tools. I mean, what they're really great at is making complexity, and I think you could make a fair argument that our world's complicated enough, and complexity is, you know, shouldn't be valued as just good in and of itself. But, you know, like a lot of people, I understand the implications if you can sort of make something complex on a small scale, like how that might lead to scaling up in a way that's sort of interesting. And of course, the dirty secret of digital fabrication is mostly the hand is what comes in and sort of finishes and fixes things, right? That sort of these, you know, workflows that look, if you go to the Met and go to a show, or MoMA and see a show on digital fabrication, some of that stuff was sort of fixed by hand, you know, and it doesn't say that on the label. And that's the sort of cutting edge, you know, the bleeding edge of technology, right? Like, it doesn't always really work out. So this object is weird, and it's like sort of furniture in this orientation, like you could sit on it, or it's a low table. It's also like a sculpture, and I, you know, allow myself to be just vague about that. You know, some people maybe would feel more compelled to really define what that is, but so then this is a rendering, a little crummy rendering, because I don't really do renderings, but for a parking garage in Kansas City that the firm BNIM wanted to do, and they had a whole wall that they wanted to treat differently, and they wanted to work with an artist for sort of 1% for the arts, and they had a great idea, I think, which is they wanted to work in the design stages with an artist. So rather than sort of putting a sculpture on the side of the building, they wanted to integrate an artist into design. And so it was a team sort of effort, but I did a lot of the sort of programmatic work to make the facade. This is it as they're sort of casting it or prepping to cast it. So it's precast concrete with ceramic components that were ram pressed and put in. It's a parking garage, so the holes provide ventilation. That's why there are holes in it. And the holes are, someone here would know, they're 4 inches diameter, which means the baby's head can't fit into it, I think. That's probably it. And so there's some of the sort of logistical things that really drive a lot of the design work, you know. This is another project that came from that sort of, which is a tile project that was here I'm laying out on the ground of the studio, the front of a residence, basically. And this is a traditional ceramic sort of in architecture maybe, where it's a tile essentially that's mortared on to an existing structure. So it's not the type of work that I do with now, which is more like a facade system where you have an air gap between the building and the substructure. This is just goes straight on. So that's the example of the install. So this is the outside of the studio. And this slide kind of represents where I really started working with Boston Valley more formally. So Boston Valley, you know, I said there used to be a flower pot factory. I went to graduate school probably 2 hours away from there in Alfred, New York, and I visited. This was maybe more than 15 years ago, and it was an old school factory where they were making, you know, historic restoration and did very little, if any, new construction. And what happened is they really made the transition to digital tools. Probably 8 years ago, they started incorporating digital tools into their business. And it was really to help aid in the historic restoration. So historic restoration used to be done, they would take blocks off the building that needed to be replaced. They would have a drafting department that would draw that stuff, all the organic sort of ornament, draw it two-dimensionally. They would scale that up and then give it to sculptors who would then look at the block, look at the drawing, make the thing, okay? That seems so crazy now that we have sort of collectively figured out a lot of different digital workflows that work really well. So now they'll scan with photogrammetry as their scanning method of choice. So they take pictures, you know, on buildings, or they have a drone that will scan, you know, take video and pictures of the building, and then they stitch that together to make a mesh of the building. Then they have people who used to work in the sculpture area, hand sculpting, now working with, they use ZBrush a lot for organic modeling of meshes, and then they sort of will break out and, you know, then cut that object in foam, send it to the mold department, and then go to a traditional manufacturing method from there on out. And why this is cool is it's sort of, it's them figuring out how to do stuff digitally that then they started applying to new construction. So they started working with architects who were designing today, the buildings that have been built. And so when I started working with them, one of the key things was we needed to mirror their factory in my facility because I wasn't going to move to Buffalo, New York. So this kiln from Italy is the same style kiln, a small kiln that they would use. So we could match processes. So all the materials that they use, I have in Kansas City, and so then it's a light situation. So now it's a sort of a research lab. This is an extrusion done at my place with the help of some people who are here. What I do for them, well, there's several things, but one of the main tasks that I do is every year they, instead of doing a trade show, they invite architects, firms that either they work with or want to work with them to do a little charrette for a week or two. And so a lot of the firms that Keith mentioned would be examples of firms where they would come in, we talk about what's sort of possible with the material if they're new to designing with it. We'll come up with some sort of idea, and we work through that process of design and troubleshooting for manufacturing over the course of 3 or 4 months every week, and sharing digital models, doing tests, and then I make the prototypes in my facility with the exception of 1 or 2 processes. And then they're sent to Buffalo, and then all the teams of architects come. It's a little bit like a reality TV show. It's not judged, but it's that feeling, you know, where architecture is a relatively small field if you're working in certain areas, and so they've all sort of know each other, and it's a friendly, competitive sort of environment of who's going to make the coolest project with ceramics. And it sort of started that way. This is the 5th year now. And last year was the first year I made prototypes, and then it's getting more and more sophisticated sort of as it goes. So this, I'll show some technical stuff for people who are interested. This is the prototype as sent to me from Payette, the firm Payette. They were interested in using ceramics as a sound absorbing material, or not so much absorbing, because we know ceramics typically, if fired hot, is a very resonant, dense material, so it doesn't really absorb sound well. It's actually a problem that Guastavino had with ceramics. For those of you who are really into ceramics and architecture, Guastavino developed a sort of sound absorbing cement tile that he tried to solve all these problems that he was having in his designs with ceramics reverberating sound so much. Anyways, the cuts are supposed to allow sound to go in and bounce around and not come out. Now, I have to suspend some of my opinions or like questions sometimes with this, mostly because I know that I might not know. You know, it might be a great solution, right? And so the cool thing for these charrettes is there's not a lot on the line, you know, and it's mostly based around trying to find innovative or interesting solutions to problems or uses with the material. And that's why an artist studio is really good at this. So the factory is like the big boat that you can't steer very easily. And so my facility, and it would be the same for another artist sort of working like I do, is we're able to sort of change much quicker than they can, try unusual things. So this is the mold. This is a pressure cast mold, which is something they hadn't really done at the plant, but I knew about, and I find benefit in this process, and so it's something we're going to start integrating into the plant. So this clay, you can see we just demolded it. Those little parts are 2 other fill holes that were connected. The little connection is a connection that will seal tightly, so the pressure involved. This is sort of a process that's in between slip casting and random pressing. And then those are some of the pieces after they've sort of been glazed and are just laying on the ground. And then that's it as it's sort of displayed after the sort of charrette. Okay, this is another one. This is from Pelly Park Pelly. They were interested in making a sort of fin that could be robotically bent or moved. It's a kind of classification of ceramics in industry called post-extrusion manipulation. And so what that is what it sounds like. It's then gets extruded out, and then you could manipulate it, you can mess with it. And there's a ton of potential there that really, like, that's an area for robotics that fits in pretty well. And that's, the implications are not hard to imagine, where you're not making a die that varies, you know, even though lots of people will think, oh, that would be cool to make a die that could move in and out. And there have been some work done there, but it's way harder than you might imagine. So the idea of being able to sort of subtly change something to make, once again, that goal that I alluded to earlier with digital manufacturing, it's just free variation. But it's not free. It's not at all free. It's like so complicated because like in Pelly Clark Pelly, they want the seams to meet and match like so nicely between the panels. And they want to have a facade system that, you know, can have this elegant motion going across it, but it's not trivial, you know, to do that. Even just the logistics of numbering the parts. How do you keep track of them? How do you ship them to the site? How do the people who are at the site, what happens when they break one? You know, how does all that whole process work? And so it's not there yet, but with this workshopping, what we're trying to do is sort of take something right to the door of production, where it could, right to the doorstep, I guess. So being able to scale, and then if there is a job, then the idea is it gets sort of worked out at that time. Here's a mold. This is actually a mold for this piece here. This is shop architects sort of designed this, and it changed quite a bit over time. They wanted to make a reciprocal arch, right? So an arch that works different than a compressive arch. So the idea was to try and use the ceramics not in tension but in compression in an arch form. And then they wanted a gradient. So one of my jobs was to sort of help figure out the design of the piece and where manufacturing might be difficult, and then also then start to talk to them about glaze. Okay, this is another piece from Pelly Clark Pelly. No, I'm sorry, KPF, which I'll put it up. This is actually at the workshop. That's the CEO, John Kraus, who is an unusual CEO that he probably knows more technically as an overview than anyone else in the facility. So he has a background in engineering, and it's a family business, but he's the sort of the one in the family that makes it all happen. Okay, so this is a ceramic lobster. So now I'm embedded in the company. I'm like this weird pressure release valve for the company. When they have something unusual that's going to gum up works in the factory, they can ask me to sort of take a crack at making it. Then also I can get their marketing team to ask me to do weird things. So they asked me to make a ceramic lobster, and Chris, who's here, Chris and I, we got a lobster, not a live lobster. I didn't want to have to use a dead lobster and take a mold of it, so we just bought like a plastic lobster online, made a mold of it, and then it's pressure cast out of the same clay that they would make the buildings out of, right? And it's a way of kind of demonstrating that the material can be lots of different things. I think that's the basic idea. So some of the research I get to sort of find to do on my own. I sort of drive it myself with my own interests and sort of present it. So the next glazes are a series of glazes that are made up of between 80 and 30% recycled glass, post-industrial glass. And the good thing is it's been successful, and now we're taking to the stage of we're scaling up. And then there's a project in Vancouver, KPF is designing, where they want to feature recycled glass glazes on a 4-tower project. So it's big, and so I have to really get it right. And so this gives you a little window into what research can look like, at least for me. You know, it's looking at sort of geekiness of ceramic glaze chemistry. This is called the Stoll chart. It's invented or discovered created, I guess, in 1917 by a ceramic engineer. And it's a way to map glazes both in the silica and alumina ratios to understand where they are in terms of surface, where they are in terms of gloss, and how they perform. So I'm mapping like the existing glazes used in the factory and then research that we're doing. But of course, it's three-dimensional, right? So I'm using Grasshopper and Rhino for this because those tools are so sort of flexible in terms of what they can be used for. So here I'm starting to just try and visualize data. So the height of those little mesh cylinders is based on the amount of zinc, right? And if it's a cone, there's no zinc, it has boron. So they're just like trying to figure out ways to understand large data sets when it comes to digital tools, because people who are architects know, but for maybe some of the artists don't know, that a lot of the digital tools really is about like managing large sets of data. That's where kind of the power really is. It's not so much modeling organic shapes necessarily, but ways of dealing with data sets. So this is a kind of experiment in ways of digitally controlling glaze amounts and mixing, sort of try and scale up the testing. And then this is a visualization also for me of figuring out how to blend colorants to create large, data sets to then test in real life. This is some of the more sort of early research, even though it's sort of, so ceramics is typically, it's opaque, of course, unless we're talking about bone china or different types of porcelain that are really thin. And for a while, I've been really interested in trying to make ceramics be able to allow light to pass through. So these are early tests. That's the same tile held up to the sun. This is a tile, a little small tile, and then held up to the sun. So a way of getting the glaze to bridge over a gap, not just fill it in, but sort of bridge over a cavity so that light can be seen through the facade. And so right now it's at sort of a scale where it's sort of ready to go for interiors, but there's a whole sort of battery of tests to do for outside for freeze thaw. And then this is, so it's not just a little dot, but it can be something bigger. And then I don't need to explain all of this stuff. One of the things I thought would be interested is I have a presentation from who's now a friend of mine, Dorina, who works at KPF, and actually I'm going to show you something else before that. This is some of the examples of a kind of using unusual workflows to try and create variation in ceramics. So this is Michael Chen designed this. This is a small townhouse. I think it's actually for his parents. But it's a facade where all the panels are extruded and then they're wire cut. So here's the sort of rabbit ear shape as it's described as. That's an existing metal or a steel die, right, for the extruder. And then the idea is to design an extrusion that could be manipulated post-extrusion, not robotically, but just with a wire cutter. And this project was done and completed, and it was done by the use of jigs and very low tech. But it led to a machine that I'm going to show you here that is a little bit top secret, but we'll look at it. This is the machine designed by somebody who got his master's in architecture at the University of Buffalo, and for his thesis project he designed this wire cutting machine. And the company decided, let's spend however many hundreds of thousands of dollars to build it. And so they built it, and now it's, you can see it moves. It's actually at 5 axes. So one axis here, one up and down, the bed itself, and then it can spin, right? So it has a wire cross between it. And so the idea is that you can make, for architect students who know about ruled surfaces, it can make ruled surfaces, right? So it's a single line that could move in space over an object that's been extruded, and you can create something. But it's sort of easier said than done, right? Like the material itself sort of fights back a little, right? And you could design the perfect system, but then when you go to implement it, of course, it doesn't work. And so it has to be a kind of closed loop of development to sort of get the thing to actually work. And right now, I would say it's sort of 90% there. Like if they got a big job where they were going to use this thing, but probably there'd be people who are scared. In fact, oh my God, you know, the last little kinks to sort of work out with it. But this is some work by SOM, sort of playing with the idea of doing something with a single extrusion that's then cut. And so this group, they designed something last year. Now we're taking a sort of another swing at it again. And this is just some of the example of the kind of like what Peter had in mind in terms of some of the types of forms, types of cuts, just really trying to explore what he was doing. But the cool thing is this is his thesis project, right? While he was a student. And he's just one of these people that just works super hard and is really on top of it, and found himself in a situation where now he's one of the key people really at the company. It's big. I think it's the largest tower in Midtown Manhattan right now. So it's bigger than the Empire State Building. The designers would probably like the fact that I slipped and said better than the Empire State Building, but that's debatable. So it's right next to Grand Central, and you can see where they've sort of tapered the shape to allow light down in. So the zoning department or the whole zoning process to build a thing like this is just, I can't imagine, you know. And one of the things that ceramics is it's this material that oftentimes in the zoning process is seen as a positive. It has a link to the past, it has a link to other historic buildings in the neighborhood or next to it. It doesn't, you know, buildings tend to sort of have more warmth or life to them that a glass sort of box tends not to have. And so these are some of, they're looking at precedents in the neighborhood. The Bostonian Oyster Bar right next door, which is great for anybody who's never been there. If you find yourself in New York, go to Grand Central, find the lowest part, you know, there. And the Oyster Bar is amazing. So this is an extruded panel. So this is engineered for construction off-site that then is sent in and installed. This is going through some of the color testing. And these projects take just years and years and years of design to make. And so this is some of the teams sort of holding up different glaze samples next to the site to see, you know, obviously how light is reflected on it. This is interesting. So you can see up here on the top, those are aluminum panels of the same shape as the Terra Cotta panels down here. And the critical thing for the designers and for the developer was how light reflects differently off Terra Cotta versus painted aluminum. And that's sort of what allowed them to sort of sell it really as something to go the extra sort of distance, both in terms of cost and complexity and risk. So these are the panels being put on. This is it. Now I think it's slated to open completely done in August this summer, but they're way beyond this photo now in terms of. So this is the basic profile for most of the facade. The soffit is a different shape, but. And there's lots of detailing and geeky stuff that we could talk about there, but we'll just move on. So this is a different project where KPF was sort of exploring ceramics, and we could probably just end on this slide, which is just some of the standard profiles that they extrude. You can see that like some of them are historic, inspired. Some of them are more generic. But they have, 80 or 100 pages of profiles sort of available from previous jobs and buildings. And for the super tall, for buildings like that, it is extrusion. That's the only way it's happening, really. It has to be extruded. anti-slip cast, or ram press, or hand press. You really, when you get over a certain scale, extrusion is the only way. And so that's because of efficiency, right? So, all right, well, I know I kind of covered a lot of ground. I feel like I jumped around. But if there are any questions, I'm happy to take a stab.
So with the Vanderbilt Tower, what was the cost of the aluminum panel on the Terra Cotta?
I don't know that. I can tell you that just the glaze alone was just under $1 million for the material. So it's hard to like wrap your head around how big some of those buildings are, you know. But for me, as somebody that buys glaze material, that was the one that really surprised me. Just to buy the material, right? Like, and it's mostly not the material that is driving the cost. But I think that most of the firms are working sort of, they're high-end boutique firms that are doing art museums, you know, small sort of buildings, 8, 10-story buildings, and you know, cities like Manhattan, San Francisco. There's a lot of work now done in London. Ceramics seems to be really appreciated by a lot of firms in London. And so one thing I didn't talk about was the carbon footprint, right? So that's some of the research that's really kind of interesting, is comparing ceramics to other materials. It does really well when you stack it up next to concrete. Aluminum, it's just like seems, you know, like so. Well, the carbon footprint of aluminum is just crazy. What it takes to go from out of the ground to an extruded sheet or, you know, profiler sheet is huge. And so a lot of firms are really concerned about carbon footprint and fall in love with ceramics because if it's designed right and well, it just lasts so long. And it has a low carbon footprint right out of the gate. So, oh my God, the glass is really terrible.
So in terms of maintenance, right?
Yeah,
yeah. The glazed piece, you don't have to ever touch it.
Yeah.
As far as like water traveling through, is it the same kind of infrastructure or?
Yeah, so when I first started working with the company, I didn't really even know what a facade engineer was. Because my background's not in architecture, even though sort of like a closet architect or something, I think. But basically, like when for these workshop things that happen annually, it'll be a team of architects from one firm. It'll be an artist, you know, usually, and then it'll be a facade engineer. The facade engineer specializes in this space that's about like this big. Like between the structure and the facade. So most of the systems on the new construction, the ceramic's floating off, and it's on a clipped system of aluminum, so there's carbon footprint there in the track. But the sort of efficiencies and benefits have to do with sort of keeping solar heat and using thermal breaks to keep the heat from going into the building. But there are weird, innovative things that have been done. There's a whole prototype that's 4 years, I think, in the making, that now is like really ready to go, where it's taking solar heat from an extruded panel. It has like a glycol-like fluid that goes through. It's basically a radiator on the outside of the building, but it looks beautiful. And then that transfers that heat either into the building or it can do the other way around. But it's not being used yet, you know. It's like it takes a firm to say, okay, we want to do this, and then it takes a developer to want to pay for it. And but I think some of that research, you know, not all of it will come into fruition as a finished thing, but some of it looks pretty promising.
Can you talk a little bit about how you connect to the history of ceramics in exterior use in Moroccan architecture, Persian architecture, which is part part of the thresholds and exterior and entries. I feel like there's a lot of relevance here, but I wonder how you connect them.
Well, my role is, oftentimes the artist is a sort of weird oddball in the group, in the mix, and that's where, I am. So I'm able to kind of just focus on what interests me, and then sometimes I'll be assigned something to take on. But, so I don't really have, anything specific to say about that, other than I could say that one of the big, big choices that happens in terms of performance with ceramics and what is possible has to do with the freeze-thaw cycle, right? So if you're designing, like there's so much Mexican architecture that I love, like it's so beautiful. Why don't we do that in Kansas City? It's like, oh yeah, I know why. Doesn't mean that some of those things can't be done here, but there's a totally different set of parameters that you're dealing with. So for Boston Valley, they do, and the other companies, not just Boston Valley. I would say there's 4 companies in the world that kind of do what they do at the level and that they do. Their big competition is NBK, which is a German company. It probably made the stuff that's on the library downtown, would be my guess. And their stuff needs to be under 4 inches tall, almost no matter what, because they have a tunnel kiln that it goes through, and it can't be taller than that. And so, to make geometric shapes or anything with volume, they have to break it up, and which most architects hate, those extra seam lines, So, that kind of went way off from the question. Right. Yeah.
What kind of digital model software do you guys use for these?
Well, for the company itself, they predominantly use Rhino, and that seems common with most of the firms that I deal with. Rhino seems like a really stable, choice. But I like to believe that I'm software agnostic. Like it doesn't matter too much. It depends on where you fit in the sort of chain of development. I guess that becomes a more important picture. But I particularly like Rhino and Grasshopper. That combination seems really super flexible. Yeah.
What's the, on the arch piece that you made, what's the durability? That follows the floor?
Yeah, so that gets the tensile strength. Yeah, if I dropped it from here, it might not break on this floor, but I wouldn't be surprised if it broke. It's like a brick, basically. But bricks are really compact, so you could drop it and chip. But if you, so the shape has a huge impact on its performance and how it will build.
How do they deal with just the wind? Because when you're on top of that Sears tower, you're moving.
Yeah, so one of the things that's really, the masonry construction of ceramics is it's kind of scary, and that buildings were made that tall in that method, right? Because there's very little sort of flex, whereas the more modern systems for facades are all engineered they can move, and they have to move. But thankfully that I don't really have anything to do with that. And I'd be to be involved in stamping anything is okay. Like, it's super scary.
What's the biggest challenge you've run into, when you're working with these 7 or however many different architecture firms doing those prototyping situations? I mean, there's certain, things about clay that not everybody sort of understands, like the strengths and like sort of the most basic principles. You run into.
I'll tell you the biggest thing is that people don't understand how sophisticated the workflows already are in order to do this. To pull it off, to have it pass all these tests, to be able to hang it 50 stories off the ground. It's super sophisticated, and it's a million moving parts to make it happen. So the clay body composition and the glaze is sort of easy. that doesn't really have an effect. But some architects don't know that. They think maybe the glaze is holding stuff together, or if there's crazes in the glaze, then that means it's close to failure below it. And so there's a kind of education there about just some basic misunderstandings that really are probably linked back to like tableware, where if somebody who doesn't work in ceramics, they're mostly around like, dinnerware and then after dinnerware, toilets, right? Those are like the kind of two areas of ceramics that like most people sort of experience, close up. And so there's some misconceptions about that.
When they come into these ideas like an arch form, that seems relatively complicated. Do you ever have to pare them down or?
Yeah, absolutely. That's the whole, it's months of the process. We're doing that now, and so, yeah, I was on a call this morning with, people at the plant. Usually what happens, it's cool because it's unlike what, Marshall, you and I kind of grew up working in the studio. So the main method was an individual working alone. It's different with wood firing. But what's neat about working in architecture is, of course, that's not the model that is real, and that is always collaborative. There's always a team. There's a sort of division of labor, and so that happens with these projects too, where you get like 7, 8 different people with really different backgrounds looking at it, and usually one person, at least one, will catch the mistake before it sort of makes its way through. Oh yeah. Question.
So you mentioned a lot about glazing and about extrusion. How much of the process is dependent on the drying process and the kilns? When is that?
Yeah. So you can, and this kind of goes to Marshall's question. So ceramics is hard because it's complicated because it's really many different materials in the lifespan of the piece. So when it's wet, there's certain constraints when you're forming it, and then in the drying process, there's certain constraints, that you have to deal with and avoid problems. And then when you fire it, when it's in the kiln, that's another set, and then when it's finally installed, it's another set. And sometimes they share, like if the wall thickness varies wildly to 2 inches thick down to 1/8 of an inch, that's going to be hard in all of those areas. But usually, there's certain decisions that are only problematic in one spot. And so, for the forming methods for ceramics and architecture, it's extrusion, and then it's slip casting, which is very comparable to pressure casting. Then there's ram pressing, which is just usually a 2-part mold, right? And then for the historic work, there's hand packing. So really the hand is the most sort of dynamic and flexible. You can do weirdest stuff with undercuts and all these sort of problems, but the efficiency is sort of lost, of course. And so those other processes require really similar drying conditions. But if you're right to ask about drying, that's a huge, there's a science of that, and you can mess that up really easily.
Thank you very much.
All right, thanks a lot.